Last class we have discussed the capacitive sensor transducers, their application like rotatory sensor for angular displacement measurement in motor, linear displacement in hydraulic system and industry machinery, general feature of variable area sensor, advantage high sensitivity for detecting small changes, second durable with few moving parts, third third is it can operate in harsh environments. Limitation of this sensitive to external noise and environmental factor require precise alignment and calibration. Design consideration we can ensure uniform dielectric medium to minimize error measurement, optimize the plate geometry for desired sensitivity and ranges. So sensitivity calculation. So sensitivity calculation we can see we know the sensitivity. Sensitivity is what is the sensitivity change in? We can say change in output by change in input. Where what is the output here? In case what is the output change in delta C? What is the input in case of when we are using the variable area, a change in area delta A change in area. So for this is the sensitivity. Again for sensitivity for parallel plate, for parallel change in parallel plates, that means change in delta C. There's a change in output by change in input. We are change in delta S, delta D. So this is the sensitivity when parallel plate is changing. The two methods we can. So sensitivity can be increased with permeability or a small plate displacement. So comparison for designing for parallel plate structures, flat plate must be used. For parallel flat plate means this in this type. This is the parallel plate. These plates are flat. So structure is flat. Movement is linear because one is fixed plate and another plate is movable. So this is move like this. So that's why movement is linear. Second application displacement sensor we can use. Another is serrated plate or teeth type. This is interlocking teeth. The structure is its interlocking teeth. Movement linear or rotatory. Both movement can be here. Application rotatory and encoder. Cylindrical type coaxial cylinder is there. Two cylinder like this. One is here like this. Another is here like this. And one is here. And this is the inner cylinder outer. Cylinder is moving up and down. So this is the coaxial cylinder movement, linear or rotatory. It move up down also it can be moved. And cylinder can be also turned around. In this way, and movement can be any type. Those are application angular or linear sensing element we can use it. Capacitance calculation we can do in this sensitivity. And next topic we will discuss about the inductive sensor. What is the inductive? So inductive sensors works on the principle of electromagnetic inductions, where where a changing magnetic field induce an electromagnetic force in a conductor or coil. So these sensors are widely used for measuring displacement, position, force, and other parameters due to their high sensitivity and robustness. Inductive sensor work on the principle of electromagnetic inductions, where changing a magnetic fields induce an electromagnetic force EMF in conductors or coil. These sensors are widely used for measuring displacement, position, force, and other parameters due to their high sensitivity and robustness. Second is mutual inductance type. Working principle mutual inductance type measure the magnetic coupling between the two coils. Mutual inductance between the two coils given by M L1 and L. Suppose this is the here, it must be under root should be here like this. So it is a correct M equal to K rule 11. M is a mutual inductance. K is a coupling coefficient between vary from 0 to 1. L1 and L2 are self inductance of two coils. Mutual inductance changes when the relative position of coil interchanges. A ferromagnetic material moves in our or out of magnetic field path. Structure: two coils, two or more coils are placed in proximity sensor. A movable core or object affect the magnetic coupling between the coils. Operation: an AC current is applied to the primary coils, generating a magnetic field. This magnetic field induces a voltage in secondary coil on the mutual inductance. The movement of coil or core changes its magnetic coupling is alternating mutually inductive and induce the voltages. Application: proximity sensors detecting nearly metallic objects. Example: security systems and industrial automation. Vibration measurement measure oscillatory movement in machinery. Displacement detecting the movement of ferromagnetic core. Movement of a coil or core changes its magnetic coupling, altering the mutual inductance and induce the voltage. Displacement sensor detect on the movement of ferromagnetic core of an object. So this is the movement of the operation. An AC current applied to primary coil. This primary coil generate a magnetic field. Suppose that this is the primary coil is this. Suppose that one coil like this. The AC supply applied on here. Suppose that this is the AC supply applied on this material. So this material start to, this is the another coil. So second is a transformer type actions. Based on the operation, a transformer, when energy is transferred from primary coil to a secondary coil through magnetic core, so the induced voltage in secondary coil depend on the magnetic flux linking the coils and number of turns in each coils. The voltage relationship is given by. So, structure the comprise the primary coils or one or more secondary coil the magnetic field so that they can produce flux. The core is movable and enabling the change in flux linkage. Operation: an AC voltage is applied to the primary coil, so producing a magnetic flux. This flux induces the voltage in secondary coil. Movement of core changes flux linkage, alternating secondary coil. Application like Lvdt, linear variable transformer, to measure the linear displacement by detecting the difference between voltage across the secondary coil. Widely used in industrial automation and robotics. Rotatory transformer measure the angular displacement by utilizing rotatory magnetic field. Load sensor detect force pressure by correlating movement of magnetic core with applied load. So we can compare with the mutual inductance type and transformer action type. So first, working principle. So mutual inductance type is work principle of change in coupling between the coils. Transformer action type working principle is flux transfer through a magnetic core. Application of mutual inductance type is proximity displacement. output induced volt and the mutual inductance type, the output induced voltage, mutual inductance and capacitance. In a transformer type action, we can calculate the only differential voltages. We can see here. So what is the advantage of mutual advantage? First, high sensitivity and high accuracy. High sensitivity means change in output. What is the definition of sensitivity? Change in output due to change in input. So sensitivity is very high because a small change in input produces a large change in output. Second, accuracy is also very high. What is the accuracy? Accuracy is nothing but degree of closeness between the measured value and true value. So both accuracy and sensitivity must be very high. Second, non-contact operation is there, reducing wear and tear also. Long operational life. For the limitation, it requires precise alignment of coils and core, sensitive to electromagnetic interferences. It also temperature changes can affect maybe its accuracy. So that's a change in temperature. We should keep the minimum. So next our topic is linear variable differential transformer. We will discuss about this topic. A linear variable differential transformer is a type of inductive sensor. Inductive sensor that measure a linear displacement. It operates on the principle of mutual inductance and produce the AC output voltage which is proportional to displacement of movable of coil. So this is the construction we can like this. This is the inner core. It is moving according to the core is moves. Link flux changes in primary and second. This is the outer core. This is the stainless steel housing is this. Inner this is the high permeability magnetic cell is this. High density glass filled polymer coil is this. Constant AC voltage. This is the primary winding is. This is the secondary winding is here. So this is the construction. This is the secondary coil. This is the core. This is the core. This is the secondary one. Output is secondary and primary. They are connected in phase opposition. That's why we can output write V1 minus V2. So these coils secondary and this is secondary and primary are connected to the phase opposition. So main component this coil. First, primary coil, a single coil bonded on cylindrical or non-magnetic material connected to AC supply. In this diagram, you can see this is the. So in this diagram, we can see this is the primary coil. This is the secondary coil. Primary, secondary are connected to phase opposition. And in second is a former. What is the former? Non-magnetic and insulating material such plastic, ceramic to avoid the eddy currents. And housing must be non-magnetic material like aluminum, stainless steel for structural strength and protecting external magnetic fields. The coils, the copper wire must be very high conductivity and insulation for reducing the losses and durability of these materials. So the working principle of linear variable differential transformer is mainly three steps. First, excitation voltage. The primary coil is energized with AC voltage to create the alternating magnetic field. And second is induced voltage. The magnetic field induced the voltage in two secondary windings. Third is a core movement. As core moves, so the magnetic flux links with primary and secondary coil changes. This change in induce the voltage each and secondary coil. Then output voltage we can write. The secondary coils are connected in series opposition. This series opposition. So the output differences we can write in this. So this is the null position. That's why primary. This is the V output. V even as both coils have same length flux. That's why E1 and E2 must be equal. So output must be equal to 0. The core is a centered, just is centered. This is the primary excitation. This is the primary AC excitation. Primary AC excitation. This is the secondary. This is the link phase secondary E2. And this is the prime. So this equal magnetic flux link both coils. Output must be 0. Next is a core displaced to one side. The core is displaced in towards the primary side, so maximum to left. So E1 is greater than, right now more flex links with primary coils. Primary coil link voltage E1 is more than compared to E2. So output must, so is produce the output. And this is the condition maximum right side. So this more in this position more flex will be linked with the secondary coil, this coil. So that's why E2 minus E1. So that in this condition E2 is greater than E1. So output we can write here. So the flex linkage is greater with one secondary coil. The output voltage is non-zero and proportional to displacement. This voltage V1 is proportional to the displacement. Displacement. The phase indicate direction of displacement. दूसरा इनपुट आउटपुट relation curve. Linear region around the null position, output voltage linearly around the null position, output voltage is nearly proportional to the displacement. Ideal operating range of LVT. दूसरा non-linear region at extreme core position, output become to non-linear due to reduced coupling. Phase sensitivity. The phase of the out of 180 by depending on the direction of core displacement. So we can see this in this diagram. This is the core position. This is the null position. Initially there is no. Generally some voltage is also included here, and up to this position LVT is up to this position LVT is linear. After this position it will start to non-linear. X-axis core displacement here. This is the core displacement, and output. This is the y-axis. Output is here. So linear. This is the y-axis. So linear output linearly increase for input positive displacement. Linearly decrease for input negative displacement. So null position output must be 0. Advantage of LVT: high sensitivity and accuracy, infinite resolution due to analog output, non-contact operation to wear and tear, rugged and reliable, linear output and wide range. Disadvantage: sensitive to temperature variation, affect the coil resistance properties, AC required in excitation, large size compared to some others enabled. So this one is sensitive to temperature variation, affected the coil resistance and core which required AC excitation, linear output and wide ranges. So this is the diagram of differential magnetic output. Phase sensitivity, the phase of the output is subdivided depending on the direction of core displacement. The extreme core position, the output become to non-linear due to coupling. Linear region around the null position, the output voltage linearly proportional to displacement. Ideal operating. Material used: made for ferromagnetic material like soft iron, nickel, alloy, high permeability. In this way, we have completed all our lecture today. For next class, we will discuss